square root solutions and completing the square. So we're going to be working on solving quadratic equations. Here's the simplest possible. X squared equals c. For what value of c? Well, we'll first transpose c. X squared minus c is 0. Now, okay, assuming for now that c is a positive number, then c is the square of a square root of root c. So x squared minus root c squared. But we already have factored the difference of squares equals a difference times a sum. X minus root c times x plus root c equals 0. And then we have a product equals 0. That means that one of these factors must be 0. If x minus root c is 0, then x is root c. If x plus root c is 0, then x is minus root c. So these are the two solutions. Sometimes abbreviate that by writing x equals this symbol, meaning plus or minus root c. So this plus or minus means two numbers, really. So for example, x squared equals 49 means x equals plus or minus root 49, which is x is 7 or x is minus root 7. Or x is 7 or minus 7. 2x squared equals 100. Well, divide both sides by 2. X squared equals 50. X equals plus or minus root 50. Now 50 is 25 times 2. So x is plus or minus root 25 root 2. Root 25 is 5. So x is plus or minus 5 root 2. These are the solutions. Here, this is a little more complicated. 3x minus 2 squared equals 36. Now we have this square, but there's this 3 in the way. So what the first thing you must do is divide by 3. So x minus 2 all squared equals 12. Now we do the square root solution. X minus 2 is plus or minus root 12. Now, okay, and then transpose the 2. X is 2 plus or minus root 12, but 12 is 4 times 3. So x is plus or minus root 4 root 3, and root 4 is 2. So x is 2 plus or minus 2 root 3, and there's that answer. Now, there's a trick called completing the square. The idea is if you, for example, you have x squared plus 6x, we want to know what to add to it to make it a completed square. Here's the idea. If x squared plus bx, well, if you had x plus b over 2 all squared and you expanded it, you get x squared. You get bx, because 2 times x times b over 2. And then, whoops, we'd also have this third term, b squared over 4, the square of b over 2. So here's the trick. Completing the square. Given x squared plus bx, we want to add something to it to make it a completed square. What we do, you take this coefficient b and divide by 2. That's b over 2, it goes here. Square that, you get b squared over 4, it goes here. And this is an equation. For example, x squared plus 6x plus what equals what squared? Well, okay. Take x squared plus 6x, take half of 6 is 3, that goes here. Square that is 9, that goes here. So x squared plus 6x plus 9 equals the square of x plus 3. Or y squared plus 7y plus what equals what squared? Well, take half of 7, 7 halves, that goes here. Square the result, 49 fourths, that goes here. So y squared plus 7y plus 49 fourths equals y, the square of y plus 7 halves. Now the point of completing the square is we can use it to solve quadratics. For example, solve x squared minus 12x plus 1 equals 0. Okay, the first thing we do is we transpose the 1. We do subtract 1 from both sides. X squared minus 12x equals negative 1. And what we want to do is to complete the square on the left side so we can solve by square roots. Here's what we do. This minus 12, half of it is minus 6. Square that is 36. And now we'll add 36 to both sides just to keep it numerically balanced. And so you get x squared minus 12x plus 36 equals negative 1 plus 36. Now this thing on the left is a completed square. It's a completed square of x minus 6. The square of x minus 6 equals negative 1 plus 36 is 35. And so now we have it in the form of something with a square. We can solve that. Take square roots of both sides. X minus 6 equals plus or minus root 35. Transpose the 6. X equals 6 plus or minus root 35. All right, now this one's a little more complicated because it has a 12 in front of the x squared. And completing the square only works for a 1 in front of the x squared. So what we'll do is we'll divide both sides by 12. And this will get t squared minus 5/12 t minus 3/12, which is minus a quarter. That equals 0. Add a quarter to both sides, so I'll move this 1/4 to the right. T squared minus 5/12 t equals 1/4. Now we'll complete the square. We'll take half of this coefficient, minus 5/24, square that, 25 over 576. Add this to both sides. So t squared minus 5/12 t plus 25 over 576 equals a quarter plus 25 over 576. This on the left is the square of t minus 5/24. Like that. Now this on the right, after you do a bit of fraction arithmetic, you get 169 over 576. So here, t minus the square of t minus 5/24 equals 169 over 576. Take square roots. So t minus 5/24 is plus or minus 169 over 576. Now it so happens that the square root of 169 is 13, and 576, the square root is 24, which is what we had before. So, and then transpose of 5/24, so you can get t equals 5/24 plus or minus 13 over 24. And okay, with a plus and a minus. With a plus, you get 3/4. With a minus, you get minus a third. T is minus 1/3 or t is 3/4. These solve this equation. 4p squared plus 2p plus 3 equals 0. Well, okay. First, there's that 4 in front of the p squared. That's mildly annoying, so we'll divide it throughout by 4. Get p squared plus 2/4 p is 1/2 p plus 3/4 equals 0. P squared plus 1/2 p plus 3/4 is 0. Okay, we'll move the 3/4 to the other side. P squared plus 1/2 p is negative 3/4. So we'll complete the square. Half of this 1/2 is a quarter. Squared is 1/16. Add to both sides. So p squared plus 1/2 p plus 1/16 is 1/16 minus 3/4. This left side is a completed square. The square of p plus a quarter. See the quarter here. And this on the left and the right side, 1/16 minus 3/4 comes out to negative 11/16. Now this is where we need complex numbers, because you have a square equals negative. That only happens if there's a square root of -1. Take square roots, p plus a quarter equals plus or minus root of negative 11 over 16. All right, plus or minus. Square root of a minus is I. Square root of 11 is square root of 11. Square root of 16 is 4. So p plus a quarter equals plus or minus I times root 11 over 4. Subtract a quarter from both sides and get p equals negative 1/4 plus or minus I times root 11 divided by 4. Now here we have p squared plus 2p plus 2 equals 0. All right, we subtract 2 from both sides. P squared plus 2p equals negative 2. Take half of this 2, that's a 1. Square that, it's a 1. Add that 1 to both sides. P squared plus 2p plus 1 equals 1 minus 2. This left side is the square of p plus 1. Put this 1 here on the completing the square. 1 minus 2 is a negative 1. P plus 1 squared is negative 1. Take square roots. P plus 1 equals plus or minus root negative 1. So p plus 1 equals plus or minus I. And subtracting 1, you get p equals negative 1 plus or minus I. You have more examples from the book. T squared plus 20t plus 25 equals 0. Solve. Okay, the same routine. First, we subtract 25 from both sides. Then divide this 20 by 2. It's 10. Square that is 100. Add to both sides. So you get t squared plus 20t plus 100 equals 100 minus 25 is 75. This left side is a completed square of t plus 10. Square of t plus 10. 75 is 75. Take square roots. T plus 10 equals plus or minus root 75. Transpose the 10. T is negative 10 plus or minus, well, root 75, it's 5 root 3. So minus 10 plus or minus 5 root 3. X squared plus 8x plus 6 equals 0. Subtract 6 from both sides. X squared plus 8x equals negative 6. Take half of this 8, is a 4. Square that is 16, add to both sides. x squared plus 8x plus 16 equals 16 minus 6. This left is a completed square of x plus this 4 here squared. X plus 4 squared. 16 minus 6 is 10. X plus 4 squared equals 10. Okay. So square roots, x plus 4 equals plus or minus root 10. Transpose, x is negative 4 plus or minus root 10. These are the solutions to this. R squared minus 6r minus 27 equals 0. Okay, move the 27 over. R squared minus 6r equals 27. Now here we go. Negative 6, half of that is negative 3, so we'll get r minus 3 squared. Square that is a 9, add to both sides. R squared minus 6r plus 9 is 27 plus 9. Left side is the square of r minus 3. Right side is 36. R minus 3 squared equals 36. Take square roots. R minus 3 equals plus or minus root 36. And root 36 is just 6. We transpose the 3. R is 3 plus or minus 6, so R is negative 3. 3 minus 6 is negative 3. 3 plus 6 is 9, so R equals negative 3, or 9. Now here we have 2r squared minus 4r plus 3. Now we have a 2 in front of the r squared, which gets in the way. So divide throughout by 2. You get r squared minus 2r plus 3 halves is 0. Transpose the 3 halves. R squared minus 2r equals negative 3 halves. Half of this coefficient negative 2 is a negative 1. Square that is a 1, add to both sides. R squared minus 2r plus 1 equals minus 3 halves plus 1. This left side is the square of r minus 1. Minus 3 halves plus 1 is minus a half. So r minus 1 squared is minus a half. Taking square roots, r minus 1 is plus or minus root negative a half, which is plus or minus I times root 2 over 2. Add 1 to both sides and get r equals 1 plus or minus I root 2 divided by 2. All right. This is a lookalike problem. 2r squared minus 4r minus 3 equals 0. So almost the same. Plus 3 is a minus 3. All right. As before, we divide by 2. R squared minus 2r minus 3 halves equals 0. Rather like this. Transpose the 3 halves. R squared minus 2r equals 3 halves. Complete the square by dividing this negative 2 by 2. Going to get a negative 1. Square that for a 1. Add to both sides. So you get r squared minus 2r plus 1 equals 3 halves plus 1. The left side is a completed square of r minus 1. There. 3 halves plus 1 is 5 halves. And okay, after a bit of nerdling, you get square roots plus or minus root 5 halves, which is 10 over 2. Add 1. R is 1 plus or minus root 10 divided by 2. So we've just solved a bunch of quadratic formulas. Next time, I'll look at this now. Next time, we'll generalize this for something called the quadratic formula. We'll solve ax squared plus bx plus c equals 0 by this pretty much the same rule we did before. We get this called the quadratic formula, and we'll see that next time.